Welcome to the first video for triangle congruence. The goal for this set of videos will be to prove that two triangles are congruent. In order to prove the triangle congruence, we're going to learn about triangle relationships using their angles and sides. First things first, let's talk about what it means to be congruent and how we can say triangles are congruent, and that is corresponding parts of congruent triangles are congruent. You see here I've got a different font with the first letters, and that's because from here on out we're going to be referring to this as CPCTC. Corresponding parts, so matching parts, think about those corresponding angles we talked about before. Matching parts of congruent triangles, so triangles with the same measure, are also congruent. So if the triangles are congruent, then their parts are congruent. Corresponding parts of congruent triangles are congruent. We're going to take a closer look at this CPCTC, and we're going to start with what's called a congruence statement. So my congruence statement for this set of triangles is that triangle ABC is congruent to triangle DEF. This is the congruence statement. And you'll notice here that I went ahead and labeled my triangles with those vertices, A, B, C, D, E, and F. And the order in your congruence statement matters. So A, B, C, D, E, F. When we're talking about the corresponding parts, they also match up in your statement. So triangle A matches with angle A matches with angle D, so they're going to be corresponding. So I can say angle A corresponds to angle D because they're in the first space. B matches with E, so B is congruent to E. And then last one, angle C and F are in the same spot, and that kind of looks like a right triangle, but I don't know for sure, so I'm just going to use 3 arches there to show that they're the same. And the same goes for the side. So if I erase the angle part of it in the statement and I focus on the sides, AB and DE are in the same spot. So AB, side AB, is going to be congruent to side DE. BC will match with EF. So BC will match up with EF. And then going A to C, or even C to A, it doesn't really matter which direction you go, but A to C and then D to F, A, C, D, F, those are also congruent. So if you're told, so in a nutshell, if you're told that two triangles are congruent, you can create this drawing. Now, I just drew one random shaped triangle, and I made 2 of them because I knew that they were going to be congruent, which means that they have equal measures. I know nothing about the actual triangle, if it's an isosceles or a right triangle or an acute triangle or obtuse. I know nothing about that. I just picked a type of triangle to draw. But from this congruent statement, I can label their parts as also being congruent based on that statement. And the ultimate goal with these next couple lessons is to be able to start with the triangles and go back and write the statement. How can we be looking at the triangles to get enough information to write a congruent statement?
So when we look at two triangles are congruent, if two triangles are congruent, then their corresponding parts are congruent. So if two triangles are congruent, then their corresponding parts are congruent. But also, if their corresponding parts are congruent, then the two triangles are congruent. So these 2 statements are related in both directions. You can start with the two triangles being congruent and end and get that their corresponding parts are congruent, or you can start with their corresponding parts and then prove that their two triangles are congruent. This, we can put in an if and only if relationship here.
But the important thing is that you can understand that you can move back and forth between these 2 purple things here. 2 triangles are congruent. Like if that's what you're given, that the 2 triangles are congruent, then you can say that all of their matching parts are of equal measure. If you know that there are corresponding parts that are congruent, then we can go back and say that the 2 triangles are congruent. So we can move either direction between these 2 statements. So let's take a look at this example. We're supposed to complete the congruent statement. So the goal is just to fill in this blank over here. So we're trying to figure out how triangle GNC is related to triangle PTF or TFP. And really these should be the same size because they are all being told that they're congruent. So, and actually in the rotation, I was fairly close, but not quite there. I think I'd have to flip this over. So if we look, we're looking at their corresponding parts, like figuring out which ones match up. So G has one arc, and according to how these triangles are drawn, F has the single arc over here. So you can kind of see that they're a little bit mirror images. I guess this would be like a line of symmetry right here, and you could swing this one on top of it. I can't slide it over because then the angles and sides aren't matching up. They're not the corresponding parts, even though it might look like it. So if we have G, it's got the single arc, matches with F with the single arc, that's gonna go first, just like G did. Then the N has 3, P also has 3, and they are both up top, so P is gonna go next. And then C is the last one with 2 arches and 2 arches, so the T is going to go there. So our finished congruent statement, and it looks like I'm missing my triangle, so let me go back and write that with enough space. So triangle FPT. So my congruent statement is triangle GNC is congruent to triangle FPT. And again, it's not just going in whatever order. You want to make sure that you're matching up the actual corresponding parts. All right, same sort of problem here. We're trying to complete the congruent statement. Triangle KMO, well, let's just start with the very beginning there. K is down here in this triangle. It has 3 arches, so I'm going to come over to the second triangle, and the triangle or the angle with the 3 arches is V, so that's going to match K. Then if I come in for M, M has 1 arch, so in this triangle, P is the one that has 1 arch, so that's going to be angle P. And then the last one, O, has the 2, and S has the 2. So triangle KMO is congruent to triangle VPS. So again, we can't just like rotate or drag, whoops. We can't just rotate or drag the triangles from like one to the other. There could be some flipping and like all kinds of different changes that happen. So we just need to focus on how it is labeled, really paying attention to, especially those arches whenever we have a congruent statement. So we've completed the congruent statement, and all their parts are congruent, so their triangles are congruent. So in this example, you don't see any triangles, but you do see the congruent statement. Triangle RST is congruent to triangle ABC, and so with this statement, the order matters. So if R and A, then S and B, and so on and so forth. So if we're trying to figure out which angle C is congruent to, we just look at the order of the statement. So C is the very last one over here, so it matches with angle T. So angle C is congruent to angle T. Angle R is the first one, so it's going to match with angle A. So those 2 parts will be congruent. AC is the line, the side AC, so that's the 2 on the end, and the A is first and then the C, so the R goes to the T. So R to T is going to be the side that it's congruent to, and order does matter. Like if this said CA, then the answer would be TR. We do want to make sure that we're keeping with that order. So since it said AC, we can say RT. Just like the next one, it says RS, it would be AB as the line segment that it is congruent to, or the side of the triangle that it is congruent to. So next, what the next video will be about is starting to actually prove that the triangles are congruent using what's called side, 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 SSS, and side, angle, side, or SAS. And that's all going to be revolving around this corresponding parts of congruent triangles are congruent. So far in this video, everything has been congruent. It's been given to you and labeled, but we're going to only be given so much information in the triangles in the next couple videos, and there's only certain patterns, certain relationships between the triangles that you can use to actually say that the triangles are also congruent. So that's what we're going to be looking at in the next 2 videos. Thanks for watching.